All right, so we are going to pick up on lecture notes week 6, and I do apologize. I forgot to upload these earlier. So Monday's lecture, if you watched it, unfortunately, you didn't have the blank sheets to follow along, but they are up now. So those are going to be found under the usual place, Unit 2, and then you just want to go to the blank lecture notes section of the unit. But we are going to pick up on page 7. Before we do though, I want to do a quick review of the law of sines that we saw during Monday's lecture. So I'll bring up um, pages 1 through 7. 1 through 7. So starting with page 1, we said we're focusing on solving oblique triangles, and oblique triangles are basically any triangle that does not have a 90-degree angle. Okay, so that means that there are two categories that it can fall into. The triangle could be obtuse or it can be acute. We said there are 4 possible cases for uh, or known information that can be given. So for instance, they might give us a side, an angle, and an angle, or an angle side angle. And if it's either one of those two, we can use the law of sines, and we would obtain one triangle solution. If they gave us side-side angle, then that would still can be solved using law of sines, but we would maybe have no solution, one triangle solution, or 2 possible solutions. So this is known as the ambiguous case of the law of sines. What we're going to be focusing on today are cases 3 and 4. So for case 3, we have side, angle, side. And for case 4, we have side, 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 which means that they give us all of the sides and we need to find all of the angles for case 4. For case 3, they give us 2 sides and the angle that is between the between the 2 sides, and then we would need to find the remaining 2 angles in the remaining side. So that's what we're going to be doing today. Let's go ahead and summarize though the different possible solutions that we can get under the ambiguous case of SSA or side-side angle. So without loss of generality, suppose that we are given a side A, side B, and angle A, which I'm going to go ahead and draw a diagram here. So we have angle A, angle B, angle C, side A, side B, and side C. And according to what we're going to be taking a look at, we're assuming that they gave us side A, they gave us side side B. Let's see, did I draw this correctly? Suppose that side A, yeah, okay, good. And the angle A is given to us. Okay, so we have side-side angle. What do we do in this case? Well, because we have this pair of angle with its opposite side, and because we have side B, we can apply the law of sines to help us find angle B. Okay, because we could write sine of angle B over B is sine of angle A over A, and these 3 quantities we're assuming are known. They're being given to us. So what we're going to do then is to be able to find that angle B, we would have to multiply both sides of the equation by side B, so B over 1. And then that would give us sine of angle B is B times sine of A over side A. And then the final step in this process of finding B, or and isolating B, I should say, is to take sine inverse of this quantity. We're assuming that we know all of these 3, so we would be able to punch them into the calculator. So we would write this as B equals sine inverse of b times sine of a over a. Now, if you recall, sine inverse on the calculator returns the reference angle. So we're actually going to call this b prime, and remember that this is only the reference angle. Then there's something that can happen here. We can actually get an error on the calculator. If you go back to example number 4 on page 5, that is what happened with this example. In this case, we were still under a side-side angle, and we had, let's see, we had angle B with side B. We had side A, and we were trying to find angle A. So we used the law of sines, and we replaced the given information. So side A was given as 25.1. Angle B was given as 55 degrees 40 minutes, and side B was given as 8.94, so we replaced that. And then we solved to isolate the sine of A, so we multiply both sides by 25.1 to get sine of A is 25.1 times sine of 55 degrees 40 minutes over 8.94. So very similar to what we're doing here, except that we were isolating for angle B, right? So we're at that step. And then what we did from there was take sine inverse to help us find the reference angle. But when we punched this into the calculator, it returned a domain error. And so we mentioned why domain errors might happen. They can happen if whatever this evaluates to is greater than 1. So if it's greater than 1, it's not possible to find an angle that'll give you sine is greater than 1. Another reason to understand, because I think what I mentioned in the lecture was, well, think about the unit circle. The values for sine, the most they ever, the highest value they ever attain is a 1. And then from there it starts decreasing to -1. But also think about it, what it represents in terms of the basic definition. It's always opposite over hypotenuse. If hypotenuse is supposed to be the largest side, then anything, and opposite is supposed to be smaller by definition, right? If hypotenuse is the largest one, then opposite divided by hypotenuse is going to be something that is less than 1, because this number is always going to be larger. So if we're saying that opposite over hypotenuse is something greater than 1, then that's not possible. Okay, so we get an error. So in our summary, what we're going to write, if punching this into the calculator returns error, so if B prime results in domain error, that means that there is no solution. There are no triangles that can satisfy the givens A, B, and angle A. Okay. Now, what if we do get a result for B prime? Okay, so otherwise, well then otherwise we have to consider two possibilities. The first possibility is when angle B is an acute angle, in which case we're going to have an acute triangle. And so possibility number 1 is the acute possibility. Under this possibility, B is B prime, simply the reference angle. Now the second possibility would be the obtuse possibility. And in this case, B is actually going to be, remember, to get an obtuse angle, that means that we're looking at something that is between 90 degrees and 180. So we would have to take the 180 minus the reference angle to get B. So think about it like this. On the number on the XY plane, if we have an angle that's obtuse, meaning between 90 and 180, in order to find what this angle B is, we would take the reference angle. So together they add up to 80. That means that 180 minus the reference angle is going to give us B. Okay, and then based on that, let's just focus on the acute possibility for a little bit. So for the acute possibility, we could then try to find the remaining missing angle, because at this point we would know B, and actually let me color code that in so that we know where we stand. We would know B. We were given A, we would just be missing C. Okay, so at that point we could calculate C by using the triangle angle sum theorem, meaning the sum of the three angles is 180. So then solving for C would give us C is equal to 180 minus A minus B, where A is the given and B is the angle we just found. Now, this wouldn't be completely done because we would still need to find side C. That's the other piece that's missing. I'll go ahead and use orange for C. Yeah, but side C is also missing. So to find side C, if you recall, I'll bring up an example. Take a look at example number 5. Okay, in this case, we calculated the reference angle and it turned out to be something that was not an error, so we got 63.9. So then we built the first possibility, which is acute. We set the reference angle will be the same as B. We calculated C. And then in order to find the missing side, C, what we did was we used law of sines. Okay, so that's what we're going to do here. We're going to use law of sines to help us find C. C over sine of angle C is going to be equal to, well, the angle and side pair that they gave us was angle A with side A. So this could be A over sine of angle A, where these two are given, and angle C we just found from this expression, right? Okay, so from there, we would multiply both sides by sine of C to isolate little c. These would cancel, and it would give us that little c is equal to A times sine of angle C divided by sine of angle A. And then at that point, we would have all three missing pieces of information. Yeah, so that would mean we at least have one triangle solution once we find all this information. Now for the second possibility, for possibility number 2, once we find angle B by applying this formula, we would then find the missing angle C. So at this point, I'm going to introduce a subscript. I'm going to call this B2 since we already had one angle B in the previous possibility. Same thing for angles. I'm going to call that C1, and for sides, I'm going to call that little c1. Okay. So again, we can take A plus B2 plus angle C is going to be 180. So therefore C is going to be 180 degrees minus A minus B2, and this is B2. And that would give us the result for the second missing angle. Okay. Now, we have to be careful because we did this for one example, example number 6, and we came across the following result. So we did C is 180 minus C prime. So in this case, we were solving for C rather than B. But then when we tried to find the last missing angle and we did 180 minus the two known angles, which is the equivalent of what we're doing here, 180 minus the two known angles, we got something that was negative. So if you get a negative angle at this point, then a second triangle solution is not possible, which means you only get one solution, the acute angle. So I'm going to write that here. If C2 is negative, then no second solution. And I'll highlight that because that is important. That means that we would only get this one possibility. Right, but if it is positive, if it's something that's greater than 0, then we would continue on to find the last missing piece, which is side C, by pretty much doing exactly the same step as what we did here. Meaning write C over sine of angle C is equal to A over sine of angle A. But now the difference is that our angle C is going to be this C2. So it'd be sine of angle C2 is equal to A over sine of angle A, where again, that has been given. And C2, we've calculated from the previous step. So then the final outcome of that would be that the side C2 is equal to A times sine of C2 all over sine of A. So again, when do we get 0 solutions? We get no solution if when you're trying to find the reference angle, you get a domain error. Then you don't even need to worry about these bottom possibilities because the problem is going to die here at this point. Yeah. If it doesn't give you a domain error and you do get a reference angle, then you're going to construct the acute possibility and come up with the missing two angles and the missing side. So that means that at this point you have one triangle solution, which is the acute possibility. Then you want to see if there is also a second triangle that's obtuse that can satisfy the given information. So the way that you construct the obtuse triangle is you make B, you create B by taking 180 minus the reference angle. And then you calculate what C should be based on that B that you just found. So you do 180 minus the given angle A minus the B2 that was calculated. And if this turns out to be negative, then that means that it's not possible to have that second triangle solution. So you would only have this solution here of the acute possibility. But if it is positive, then you continue on with the work to find the last side, in which case, if you make it to this point, you'll have two triangles instead of one. Okay. Any questions? That's a lot of information, but just wanted to write out that summary so that you can read it over later on. Yeah.
I wanted to know, like, I know you're explaining the whole like steps, but I want to know if there's any way I could see an example, or we could do an example.
Yeah, so okay. So yeah, we can let's see. Let me let me look at the textbook if, to check get a different example. So there is an example. This is from example 5. Example 5 would be a good example for it from Monday's lecture, but just so that we could refresh, let me find some different angle measurements. Okay, so here's one. Okay, so here's one. Let's try this example. So we're going to solve triangle ABC. If angle A is given as 96.80 degrees, side B is given as 3.589 feet, and side A is given as 5.818 feet. Okay, so again, let me do diagram first. Oh, that came out too small. Let me try that again. Okay, so I'm going to call this A, B, and C. And A is given to us as 96.80 degrees. Side B, which is opposite to angle B, is going to be 3.589 feet. And side A is going to be 5.818. And that's in feet. Okay, so what are we missing? Well, we're missing our angle C, angle B, and side C. So I'm going to color code those the same colors that we had them in the summary. Let's see, in the summary we used pink for B, green for C, and orange for side C. So those three we need to find. Okay, so since I have A and angle A and side A, and I know side B, then I can find angle B using law of sines. So I'm going to do sine of angle B over side B is equal to sine of angle A over side A, because again, this information is given. Okay, so A I can plug in, side A I can plug in, and then side B I can also plug in. But before we do, let me just solve completely for sine of B. So I'm going to multiply both sides by a B so that it cancels out there. And we're going to get that sine of B is equal to B times sine of A. I'm just multiplying across the numerators, right? Sine of A times B is the same as B sine A, all over A. Okay. So now let's replace. B is 3.589. Angle A is 96.80 degrees. And side A is this 5.818. So now what we want to do is we want to find B. So I'm going to take sine inverse of this value. So I'm going to have B is equal to sine inverse of 3.589 times sine of 96.80 divided by 5.818. And we're going to enter it into our calculator. Make sure that you're working in degree mode. Okay, so I have sine inverse 3.589 times sine of 96.80 divided by 5.818. And we get approximately 37.77 degrees. I'm rounding to the nearest hundredth of a degree because here they gave us to the nearest hundredths. They give us 2 decimal places, so I'm going to use 2 decimal places. Okay. Now what's important to remember here is that this is the reference angle. Okay, the calculator is returning to us reference angle. All right, so now we look at the different possibilities. Possibility number 1 is the acute possibility, in which case the angle B will be the reference angle, so it's going to be 37.77 degrees. And then we also have to consider the obtuse possibility, in which case angle B is going to be given by 180 minus the reference angle, so 37.77. And that is going to be, let's see, 180 minus 37.77, 142.23. And that is in degrees. Okay. So let's focus on finding all of the quantities that are related to acute first. Yeah, so the next, we already have, let me actually box this. This is one of the unknowns. Okay, that was B. We still need to find angle C and side C. So the easiest thing to find at the moment is angle C, because I have these 2 angles now, which means I can use triangle angle sum to solve for angle C. So I'm going to get that A plus B plus C is 180. Which means that C is going to be 180 minus angle A, which is 96.88, minus angle B, which we just found is 37.77. Okay, so what does that give us? Let's see, 180 minus 96.88 minus 37.77. It's 45.35. So now we have C as well. Okay. Which means there's just one more piece of information that's missing, and that is side C, the side opposite to angle C. So what can we use to help us find that? Well, I have angle C now. I am trying to find side C. I also know angle A and side A. So we can use the law of sines to help us here. We can write C over sine of angle C is equal to A over sine of angle A. Because we know A, both the side and the angle, and we just found out what is angle C. So we can plug that information in. We're going to get C over sine of angle 45.35 degrees is equal to 5.818 divided by sine of angle A, which was 96.88. Sorry, 96.80. So again, since we're solving for C, just multiply both sides by sine of 45.35. And it's not going to fit in there, so I'm going to write dot, 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 but then the dot, dot, dot is referring to the same quantity. So these are going to cancel, and we're going to get that side C is 5.818 times sine of 45.35 degrees divided by sine 96.80. So at that point, I'm going to punch in the calculator. 5.818 times sine of 45.35 divided by sine of 96.80, and we get approximately 4. Remember, this is the length, and the lengths they've been giving them to us to the nearest 3 decimal places. So we're going to say that C is approximately 4.168, and that would be in feet.
Can I ask a question?
Yeah, of course.
So when you're setting the law of sines equal to each other, you're choosing it based on, you're going with the given first, right?
Yes.
Yeah.
Yeah, exactly. Because we do have the option. I mean, we would have the option of using like side B and angle B, because at this point, by the time we're at this step, we already know what B is. But I am choosing to stay with only using the given. So I'm trying to avoid as much as I possibly can of my own work, even though sometimes it's impossible in these circumstances, right? Like to calculate C, I still need to use B. But I am trying to stick to only the given. All right. You guys have any other questions?
For like how you multiplied sine of 45.35 from each side, is it always on the right side where you put the 3 dots? So since that would be sine 45.35, every time you do it in that way, would you just simply input that next to the 5 where the 5.818 is at?
You could write it like for instance, we could write it like sine 45.35 and then times times 5.818. The only thing with that is that it can get sometimes if we're not careful, if we're writing things very quickly, we might get confused between what's inside of the sign versus what's outside. And so what I mean by that is let's say that we write something like, okay, this is sine of 45.35, and then I have 5.818 because I'm multiplying together. I just don't want you to get confused between the angle that belongs to sine and then this factor of 5.818, this coefficient. So I always like to write the coefficient in the front just so that there's no confusion as to whether this is being multiplied to the whole of sine or just to the angle.
Oh, okay. Yeah, because when you told us that we had to multiply sine of 45.35, I thought that maybe like we would have to like when we would multiply that, I thought that the sine of 96.80 would change or 5.818 would change.
Okay, so yeah, no, well, the 5.818 won't change until we actually punch it into the calculator and we take the product. And then
Okay.
the 96.80 won't be affected because when we multiply by, let me actually write it down. When we multiply by the sine 45.35, in the denominator, it's as if it had a 1. So so I'm doing this, right? 45.35 degrees. It's like I'm writing it over 1. So when we multiply it together, only these two in the numerator multiplied together. In the denominator, it's like we're doing sine times 1. So we just get sine of 96.8.
Oh, okay.
Yeah.
Thank you.
No problem. Good. Any other questions?
So without solving it all the way through, there's no way to know how many answers there's going to be, right?
So there actually is a way, and I'm going to share with you guys a video that is very helpful. They explain it's a different perspective on it. There is a way, but as far as the ones that I'm going to show you, the examples that I'm going to show you, we're just going to be solving it all the way because that's likely what they're asking us to do anyway, to solve the triangle. But yeah, you can also use the lengths of the sides to help you determine whether we're going to have no solution or one solution. Yeah. All right. So now let's take a look at the second possibility, which, by the way, on exams that I've given in past semesters, there's always a problem that shows up like this. And a lot of the time, students forget to write the obtuse case. They only write the acute case. So you always have to check and see if the obtuse possibility will be a solution. So just be careful and be on the lookout for that. Okay, so here we've already found B, right? We found B. I won't box it yet because we need to make sure that the obtuse really exists. So that is going to be determined when we take A plus B plus C is 180 and we try to solve for angle C. So we're going to have C equals 180 minus angle A, which I guess I'll replace right away. That way we don't run out of space, minus angle B. Now, angle B here for this possibility is 142.23 degrees. And so what I'll do is I'll underline it. And then 96.88 comes from angle A, which was, oh, and I keep writing 88, but it's not 88, it's 80. So that should be 80. Oh, you know what? I wonder if I made a mistake here then. I probably did. Let me double check. Because it should be 180 minus 96.80 minus 37.77. Yeah, it should be 45.43 here. Apologies. My own handwriting. Because I didn't erase it properly in the diagram and I just kept writing it 88 everywhere else. So it should be 80. And I think here I did put it in okay, so that should be fine. Oh, actually, you know what? Maybe not, because here it should be 43, so I'm going to recalculate that. Okay, so in the calculator, if instead of having 45.35, I have 45.43, and I enter this calculation, I'm going to get 4.170. So these are going to change. $1,740, so just 174. Okay. Okay, so back to this problem. If I try to calculate what C is going to be, I'm going to have 180 minus 96.80 minus 142.23. And that gives us a negative angle for C. Do you guys remember what this means? If we get a negative angle, what does that mean for possibility number 2?
Not a solution.
Yeah, not a solution. Good. So there is no second solution. And that is this little note that we have as part of our summary. If the second angle C is negative, then there is no second solution. So this problem had only one solution then. It is this angle B, angle C, and this side C. All right. Any other questions before we continue?
Are we going to get a problem where there's no solutions?
Yeah, there could be a problem like that. It will look very similar to problem example 4 on page 5. Okay, so the way you're going to realize that there is no solution is if you get an error when you're calculating the reference angle. Okay, so do try to go back to example 4 and you can rework the problem and you'll see that there's no solution. Okay.
So is there a difference between 0 solutions and impossible to solve?
So impossible to solve, well, there's two places where we might have that impossible to solve. It might happen here because we'll get a domain error. Or the second way it can happen is here if we get a negative angle. So if it happens here, this is the earliest place where we'll see the error. That means that there are no possibilities. There's no possibility 1 and no possibility 2 because we've reached this roadblock before we even got to that point. So if you see it here, then there's no solution. If you see it here, however, then that means that there's only one solution. So I guess what I'm saying is there isn't really a difference. The difference is where you encounter the impossible to solve. Well, okay, let me backtrack on that. I guess, yeah, okay, there is a difference. So impossible to solve would be more like if they don't give you enough information. Like for instance here, they gave us 3 pieces of information to be able to solve it. If they only gave us 2, then that's impossible to solve because we don't have enough information to even try to get the reference angle. But if you have no solution, that means they gave you all the necessary information and you came across an error at some point.
I see. Thank you.
Mm-hmm. Okay. All right, so that brings us to the law of cosines now. We're going to start by looking at the formula. So, like always, I'm just going to draw a diagram first. We're going to say if you have this triangle ABC, then law of cosines tells us the following, and there are 3 versions of the formula. The first version tells us that a squared is equal to b squared plus c squared minus 2bc times cosine of angle A. The second version has b squared is equal to a squared plus c squared minus 2ac times cosine of angle B. And the last version is c squared is equal to a squared plus b squared minus 2ab times cosine of angle C. And we can use this formula when we have the following cases. We can use it for side, angle, side. And we can use it for side, side, side. And by that I mean that information is given to you. A side, an angle, and a side, where the angle is in between the 2 sides, or when you have side, side, side. Example 7 reads, the surveyor wishes to find the distance between two inaccessible points, A and B, on opposite sides of a lake. Okay, so let's just draw that really quick. We have a lake, and there are 2 points on that lake, A and B. They're not accessible. While standing at a point C, so the surveyor is somewhere at a point C, she finds that side B measures 259 meters and side A measures 423 meters. So what that means is that we're forming a triangle between the 3 points. And side A, which is opposite to angle A, measures 423. And side B measures 259. They also tell us the measure of angle ACB. So here's ACB. It's the same as angle C, but they're since originally these were just points and not necessarily a triangle, they're being very specific about what angle they're referring to. But it's the same as angle C. It's 132 degrees 40 minutes. Now what they want us to find is the distance C. So that means we need to find the distance across the lake. All right, so let's see, what case are we in? What information is given? Well, we have the side, we have the angle, and then we have the other side of that angle. So that means that we're in the case side angle side, which calls for law of cosines. So out of these 3 formulas, we're going to be using the third, since that is the one that has C already isolated, plus the angle that's given is angle C. So it's really the only formula that we can apply here. So we're going to rewrite that. C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. And actually, just to cut on the work, I'm going to already take the square root so that C is completely isolated. Okay, so all I did here was take the square root of both sides to get C by itself. Okay, so then we'll get the square root of, and then A is 423 squared plus B is 259, and that's squared, minus 2 times 423 times 259 times cosine of angle C, which is 132 degrees 40 minutes. Okay, so now we punch it into the calculator. We'll get a 423 squared plus 259 squared minus 2 times 423 times 259 times cosine of 132 degrees and 40 minutes. Okay, so we get approximately 628. I'm going to round to the nearest whole number because the distance was given to the nearest whole number. So 628 meters. Okay, questions here? Let's take a look at example 8. So for this
I'm sorry,
one,
I got a question.
yeah.
So the way that you, how you, what was I gonna say? Sorry. How would you be able to determine if whether it's side angle side or like for the cases?
Good question. So the way we do it is we take a look at what is the given information. So since they gave us side A and angle C and side B, that means they gave us the side, the angle, and the side that is in between. So this
Okay.
means that angle is between the two given sides. That is
Okay.
in contrast to something like this example. So we're going to compare these two. Let's see, what's the best way? Okay, well, I'll just do it like this. In this example that we worked earlier, they gave us angle A, side B, what's this one, and side A. So if I look at the blue highlighted portion, I have a side, and an angle. But the angle is not in between the two sides. It's outside of the two adjacent. So here we write this case as side, and then angle.
Okay. Thank you.
Yeah, no problem. Okay. All right, so here's example 8. Example 8, we have solve triangle ABC, and this is a typo that I meant to correct before I uploaded, but this should be B is 12.9 meters, and then C is 15.4 meters. So I can go ahead and cross this off. That should be C. So if we draw our diagram, and is it okay if I remove this bottom page? Right, so taking a look at or drawing a diagram for the given information for this triangle, I'm going to say this is angle A with 42.3 degrees. I'll call this B and this C. Side B, which is opposite to angle B, is going to be 12.9 meters. Side C, which is opposite to angle C, is 15.4 meters. And don't worry too much if the diagram isn't consistent with the measurements. Like for example, 15.4 looks a lot smaller than the 12.9 meters. That's okay. If it really bugs you, you can just switch over the B and C and then switch these two measurements. But I'll just leave it as is. It doesn't matter too much. What matters is that it gives us a visual for what's the given information and what is it that we're missing. Okay, so for the given information, I have a side, I have an angle, and I have a side. Right, so that would mean that we're under the case side, angle, side, which calls for the law of cosines. Now, as far as what's the information that's missing, well, we have the two missing angles, which would be angle B and angle C. We also have missing the side A. So those three pieces of information are what we need to find. Okay. So the first thing that we can do is we can use the law of cosines, the first formula, the first out of the three, because since we have angle A, we're able to find side A. Okay, so as a guideline, your first step is to use the law of cosines to find the missing side. In this case, the missing side is side A. So we're going to write A squared is equal to B squared, which is this 12.9, plus C squared, which is this 15.4, minus 2BC, so that would be minus 2 times 12.9 times 15.4 times cosine of the angle. Oh, actually, sorry. I think did I have, yeah, that should be okay. It should be B and C, yeah. Times cosine of angle A, which is 42.3 degrees. All right, so just to rewrite it again with the square root now, because I'm going to take square root of both sides to cancel out that square. And we're going to get that A is equal to 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3. So if we punch it into the calculator, 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3. That gives us approximately 10.5, rounding to the nearest tenth because the lengths are given to the nearest tenths. So A is approximately 10.5. That would be in meters. All right. So far, any questions? And if you're wondering where is this coming from, I forgot to write the law of cosines up here, but basically we're using law of cosines, the first formula that reads as follows: a squared is equal to b squared plus c squared minus 2bc cosine a. Right, so that's the first step. The second step is to now try to use the law of sines to find the smallest of the two missing angles. And here's the reason why. So let me just first write that. Use law of sines to find the smallest of the two missing angles. Okay, why would we want to do that? Well, if we find the smallest of the two angles, we know that the smallest angle cannot be obtuse, right? So therefore, we wouldn't have to worry about considering the two possibilities for the ambiguous case of sines. And we would just find one triangle and that, or one angle, and that is the one that we're interested in. Okay, so right here I'll write because the smallest angle cannot be obtuse. So we don't have to worry about the obtuse case. But then that begs the question, well, what is the smallest of the two angles? Because none of these two are given, right? So if they're not given, how do I know which one is the smallest one? Well, here's what you should keep in mind. Keep in mind that the angle is always going to correspond to it's always going to have a relationship with the side. So what I mean by that is the following. Let's say that, and I'm going to put this away for a second. Let's just say that I'm forming this angle here, right? Well, the bigger the angle is, the longer this piece has to be, right? This piece here. Okay. So if I actually make the angle smaller, the angle between these two sides, well then that automatically means that this side here is shrinking. It's becoming smaller and smaller. If I make it larger, well then that side is going to keep growing longer and longer. So what that means is for the triangle here, we're going to take a look at the two sides, see which one of the two sides is longest, and that is going to correspond, or which one, I should say, which one of the two sides is shorter, and that is going to correspond to the smallest of the two angles. So what is the smallest side? Let's start there. What is the measure of the smallest side that corresponds to unknown angles?
B.
B, good, yeah. So if you take a look at B, we have 12.9 meters in comparison to the 15.4. This is the smallest, right? So that means that B has to be the smallest angle. Okay, so here I'll write the smallest angle will be opposite to the smallest side. All right. So in this case, we're interested in finding B, which means that we can use sine of angle B over side B is equal to the only angle and side pair that we know right now is angle A with side A. So we're going to write is equal to sine of angle A over side A. Now we can replace the known information. B was given to us as 12.9. Angle A was given to us as 42.3 degrees. And side A we just found as 10.5. So from there we're going to multiply both sides by a 12.9. These are going to cancel. And we're going to get sine of B is equal to a 12.9 times sine of 42.3 degrees all over a 10.5. Where again, notice that I'm writing the 12.9 in the front simply because I want to avoid any confusion with multiplying into the angle. Okay, and then what does that mean for B? Well, that means for B that we're taking sine inverse of this quantity. So 12.9 sine of 42.3 divided by 10.5. And what does that give us? Well, let's see. Sine inverse 12.9 sine of 42.3 divided by, oh, and I think I closed the parenthesis too. No, that's fine. Divided by 10.5. And we get approximately 55.8, or we're rounding to the nearest tenth of a degree because that's the number of decimal places that was given for angle A. Okay, so B is approximately 55.8 degrees. All right, now we're almost done, but there is one piece of information that we don't have yet, and that is angle C. Any ideas as to how we might be able to find angle C?
Could we
you
just use the
Triangle
angle
sum
sum theorem?
Yeah, very good. Yeah, the triangle angle sum theorem, because we just found angle B and they gave us angle A. So we can just use triangle angle sum to solve for C. Good. All right, so then that would be our last step, step 3. Use triangle angle sum theorem to find the missing angle. And so we have A plus B plus C equals 180. And so that means that angle angle C, which is what we're solving for, will be equal to 180 degrees minus angle A, which was given, minus angle B, which we just found. And then if you punch it into your calculator, what do you guys get?
81.9.
81.9? Awesome, thank you. 81.9. So that would be for C. And so in general, those are the steps that you can follow to solve a triangle that has the form side angle side. Right, we're going to take a look at one last example. And that is an example for solving side, side, side. Is it okay if I flip this page over? They're asking us to solve triangle ABC. Side A is 9.47. Side B is 15.9 and side C is 21.1 feet. Okay, so let's go ahead and draw. All right, so this looks like the longer of the 3 sides. I'm going to call this side C with 21.1 feet. That means that opposite to that side will be angle C. This one looks like the second largest, so I'm going to make this side B with 15.9 feet. And that means that opposite to that we'll have angle B. And finally, this will be 9.47 feet. And opposite to that will be angle A. All right, so because the 3 sides are given, but no information about the angles, this is a case of side, side, side. Which means we are still, we can still use the law of cosines to help us find the missing information. So what is missing? Well, we're missing angle A, angle B, and angle C. So again, I'm going to give you some guidelines for the steps. Step 1, you want to use the law of cosines to help you find the largest angle. So which of these angles is the largest angle, and how do you know?
Angle C,
Good, yeah. And what's the reason?
it has the largest side.
Good, it corresponds to the largest side. Very good. Okay, so in order to be able to find angle C, I need to take a look at the law of cosines and see which of the three formulas has angle C. Well, that would be this last one. So this is the one that we're going to use. And we're going to use C squared is equal to A squared plus B squared minus 2AB times cosine of angle C. And before we plug in any of the values, we can try to solve for angle C as much as possible. So that means I can subtract A squared from both sides and B squared from both sides of the equation to get C squared minus A squared minus B squared equals negative 2AB times cosine of angle C. Give me 1 second, guys. Okay. And then from there, remember our goal is still to find angle C, so I need to isolate it. That means I can divide both sides by the negative 2AB, and that's going to give us that cosine of angle C is equal to C squared minus A squared minus B squared divided by negative 2AB. And finally, if you have cosine of an angle with the known value, and we do know that value, or we are going to be able to calculate it because all of this information is given, all of those sides are given, then I can take cosine inverse. So C is going to be cosine inverse of this information. So let's actually plug it in at this point. We said we have C squared. Maybe I'll take up 2 lines, that way it doesn't get too messy. So C squared would be a 21.1 squared. Oh, well, maybe not that line. I'm going to run into the other. Okay, so 21.1 squared minus A squared, so that would be minus 9.47 squared minus B squared, that is 15.9 squared, and then divided by negative 2 times A, which is 9.47, times B, which is 15.9. Okay. And let's see what that gives us. We're going to get cosine inverse of, oh, actually, I think I punched the wrong button. Okay, so cosine inverse of, I have to be very careful here because I do have these subtractions happening in the numerator. So I'm going to encompass the numerator in parentheses. 21.1 squared minus a 9.47 squared minus a 15.9 squared. Okay, and then close the parentheses to close the numerator, divided by, I'm going to open parentheses to encompass the denominator, a negative 2 times 9.47 times a 15.9. Okay, so now I'm closing the denominator and then closing the cosine inverse, and that gives me approximately 110 degrees. Okay, I'm going to round to the nearest whole degrees. Okay, so approximately 110 degrees. So notice for cosine inverse, the calculator does return to us an obtuse angle. It can return to us an obtuse angle. That is not the case for sine. Okay, for sine inverse, it just returns the reference angle, but here it actually returns to us the real angle. Okay, so that's C. The next step is to now use the law of sines to find any of the two missing angles. So we're missing A and B. Doesn't matter which one you pick at this point, because if C is obtuse, it will show up. And since we picked the largest angle, the remaining two are going to have to be acute. So it doesn't matter which one you pick. I'll just start with A. Okay, I'll have sine of angle A over side A, which is 9.47, is equal to the only angle and side pair that I can use right now is angle C and side C, because that's the angle that I know, right? I don't know A and I don't know B. So I'm just going to use sine of angle C, which is 110 over side C, which is 21.1 feet. So now multiply both sides by 9.47. These are going to cancel. And we're going to have sine of A is equal to a 9.47 times sine of 110 degrees divided by 21.1. Which means, again, if we want to find A, we're going to have to take sine inverse. So A is going to be sine inverse of this information here. So now we punch it in. Sine inverse of 9.47 times sine of 110 degrees divided by 21.1. We get approximately 25 degrees. So again, we have just one angle left to find, that's angle B. And at this point, since we have both C and A, we can use triangle angle sum theorem to help us find that last angle. So step 3, use A plus B plus C, which is triangle angle sum theorem equals 180 to find the missing angle. I'm running out of space, so I'm going to write it on a sticky note. I have A plus B plus C equals 180. So that means that B is going to be equal to 180 minus angle A, which is 25. We found it here. Oh, sorry, that's not coming out. Okay. And then minus angle C, which is 110. Okay, so that's a 180 minus 135. So B is going to be 45 degrees.
Professor, would you please show me how you input the step 1 equation into the calculator? I'm not getting 110.
Yeah, give me 1 second. So it looks like this, but I can enter it again. What you want to double check, because usually the common mistake that happens when inputting this type of problem is that you don't have a parenthesis around the numerator. So just make sure that you have cosine inverse open parenthesis, that's for the cosine. Then we'll have another open parenthesis, which means the beginning of the numerator. So 21.1 squared minus 9.47 squared minus 15.9 squared. At that point, you want to close the numerator and then have divided by, and then again, I have an open parenthesis for the denominator, the -2 times 9.47 times 15.9. I'm closing the denominator, and then finally I close the cosine inverse.
Oh, perfect. Thank you. It was the denominator that was messing me up.
Oh, okay. Yeah.